So welcome to my interview today. My interview partner today is David Basanta from the Moffitt Cancer Center.
Yes.
And David, why don't you just introduce yourself just quickly?
Yes, the obvious is I'm David Basanta. I'm from the Moffitt Cancer Center. I work at a very unique department. So Moffitt is a hospital in Florida, and it's probably the only department in a hospital that you can find in the United States. So it's the only department of integrated mathematical oncology, and together with Sandy and Kasia, we were the founding members of it. So, yes.
Yeah, wonderful. Great. So we talk about Moffitt a little bit later.
Yes, okay.
First, I want to reminisce in how we met the first time. I don't
How
have
do
to
we-
remember this, but I do. So let me go.
Okay,
So,
because you and I have seen each other in quite a few conferences,
Yes,
right?
that's
so
right,
yeah,
yeah.
it's,
but I think the very first time we met at the swimming pool in Orlando.
oh wow,
There was
oh,
a big meeting at this hotel, and there
That's
was
exactly
this
right.
wonderful pool,
Ames.
Ames or some Ames,
Yes,
yeah.
yes. And
And
you were
I-
with Heiko, right?
And I was swimming there, and I
Yes.
came out of the pool, and then this guy approached me. I was like completely in my swimming things, and hey, Dr. Hillen, and I, who the hell is this?
Who the hell is this guy? And why is he swimming, right?
Yes, exactly. So that was you.
Yes. So that was maybe 2012.
Yeah, could be.
Yeah, it was a while ago. So yeah, 12 years ago.
Yeah.
If that's
Yeah,
the case.
12
If I
years
got
ago
this
now,
right, yes.
Yeah, awesome.
And we keep meeting each other in lots of math onco conferences, math bio
Yes.
conferences,
Yes.
SMBs, and so on.
So tell me about your way. How did you get into cancer modeling?
Yes, so I don't think my path is particularly conventional, although I think that for most mathematical oncologists, no path is conventional.
Right.
But I'm a computer scientist, and I started working on something called genetic algorithms. And the way I started developing these genetic algorithms were to make them more and more like real evolution. So the
Yeah.
idea was that you use this really crude approximation of how evolution is supposed to work. And my supervisor at that stage, Mark Miodownik at the UCL in London. So he decided that the way to go is to actually make them more and more realistic, more and more like biology. At some point, biologists actually came to him and said, like, this is actually very cool. We can use this the other way around that you're expecting, which in genetic algorithms, you have a real problem and you use biology to try to figure out how to solve it. This is the other way around. It's like, what you already have a computer model of biology. What if we asked biological questions to it? So I got very interested in cancer evolution through that, because it's like one of the easiest low-hanging fruit that you can use computational models of evolution in ways that are actually sort of applicable to biology and to maybe the clinic, which is the hope.
Interesting. So where was this?
Yes, so I did my PhD in London at King's College,
okay.
and my collaborators were at UCL, so University College London, and they used to have, not anymore, but they used to have something called the Ludwig Institute for Cancer Research. There's a bunch of branches out there in Zurich, in California, in Australia. So they have one in London that is now in Oxford. And yes, through that, I got really interested in really pursuing the idea that you can use computational models and mathematical models to understand cancer.
Okay,
Yes.
interesting. Yeah. And so you thought this would be an interesting way to continue or to work on?
I loved it. I loved it.
okay.
So my PhD is in material science, and as much as I love my supervisor, it didn't really sort of drive me in ways that cancer evolution did drive me. Like
Nice,
I got
yeah.
so interested, and obviously it helps that is something that I believe will have an impact on how we treat patients. So it's something that has like this use as well. So it's intellectually fascinating. And from the practical point of view, I think it's quite useful.
It's quite useful, I think so too. Yeah. So now let's talk about the cancer center.
Okay,
the Moffitt Cancer
Moffitt,
Center.
yes.
Yeah. So how is this working at Moffitt? What do you do? What's your everyday life?
Oh, my everyday life. Who has an everyday life when you're an academic, right? I mean, for starters, today is a regular day for
Today is
me, and we're
every
here in Toronto talking to you. So, what is a normal day? But so as I said, we are like the only math department in a cancer center that I know of. So Moffitt is an NCI designated cancer center, which basically means they do all kinds of basic research to applied research. So as they like to say, from the bedside to the bedside. But because we're a mathematical department, you can actually say from the blackboard to the bedside.
okay,
So
cool.
it's a
Right.
slightly different angle to it. And we just basically spend a lot of time talking to cancer biologists, cancer epidemiologists, clinicians, so clinical researchers, oncologists, pathologists, all kinds of cancer doctors. And we also have lots of mathematical people in our department, so physicists, computer scientists, and mathematicians. And every day is a slightly different adventure, but usually involves talking to all kinds of people and sort of discussing models, discussing data, and discussing projects.
Now, as you mentioned data, if I observe our area in the last 10 years, the data availability has changed quite a bit.
Yes, so
Do
much.
you find this an opportunity, or is this a bit scary?
The reason that we actually moved from a math department, which is where Sandy, my chair of the department was, in Dundee, to Moffat, is because we were not scared by data. We actually wanted the data. We really
I
wanted
see.
to make
Okay.
sure that
Yeah.
our models not only were like a way to converse between different mathematical models to the math models, but actually something will have like a translation into the hospital, right? So to me, it's an opportunity, but I do recognize in your question something that's very important, which is that data is something that's grammar models may drive the use of the models, at least for some people, but it's a risk if that's the only thing there is.
Mm-hmm.
You can be too much in love with the data and not fully utilize the power of math modeling. The power of math modeling is that you can structure data inside, but it allows you to think bigger.
Yeah.
And I think that one of the things that we math modelers bring to the whole cancer research community is that we are not beholden by data. What we behold is by ideas, and we ground these ideas into reality using data.
Yeah.
But ideas should come first.
Oh, that's a very good take on
Yeah.
it. Yeah, that's interesting. Now, in your case, I know you worked a lot on bone cancers,
Yes.
right? So, do you think you have an impact on the bone cancer treatments?
Yes and no.
Okay.
Yes. So the first one is that we have, I think, as math modelers, and it's very difficult to explain to people in conferences and in journals. Yeah, I mean, one of the outputs a scientist has is publications and talks, right? So you go to a place, you work with a cancer biologist, like in my case, someone who specializes in bone cancers, and you discover a few things. And the idea is, okay, so this is complete new biology that you could not have figured out yourself
Yeah.
without the use of math modeling, because there's
Okay.
lots of different sort of angles and questions that are not approachable if the only data you have is cellular data or molecular data. There's a question of time scales, it's a question of the sort of sparsity of data. There's a question of a lot of things that only the synergy of math models and data can actually answer. But I think it's a lot more fundamental than that. And this is something that I don't think a lot of people in the community recognize, which is biologists themselves change and clinicians themselves change through
Yes.
conversations with us. And there's a process of
Ah.
education that works both ways, that you cannot put in a paper and you cannot put in the shape of a talk. But I talk to a bunch of people in Moffitt, and the way they think, the way they approach questions, and the way they approach the way they deliver treatment has changed just because they have talked to us. So in a way, the impact on the cancer research and cancer treatment is direct through we have come with a new approach which you should use to treat people differently, but also by talking to people who treat cancers in people, so they start thinking in a more systematic, more evidence-based way.
This is a very good way to take it. Yeah.
Yeah.
To see it. But wonderful. Now, David, I want to talk to you also about the next generation.
The next
of
generation,
researchers
the
and
better
young
generation.
people.
Yes, yes.
But you work a lot with young people and students and so on, right? I think,
Yes.
in Moffitt?
That's correct. Yes, we train through undergrads from the local university, USF, and we also have our own PhD program. I happen to be the major director of the mathematical oncology PhD program.
You okay? So
Of all people, I know.
I take it as a warning. That's
Oh yes, yes, exactly. So,
so if you go, you have to deal with him.
you
so,
have to deal with me. Good news, bad news, we'll see. But the important thing to me is that I come from a different generation that was trained in just normal math or normal computer science,
Yeah.
and we have to sort of convince biologists to work with us. And I think that the new generation will have an easier job because they can come to places like Moffitt, places like Mayo Clinic, places like Cleveland Clinic, places where there's actually people math modeling already. And that is going to be easier because then you have collaborations and you have people who already expect to know what it is to collaborate with a mathematical modeler. On the other hand, the generations that are coming now to our PhD program are people who are expected to not just know math. They know the biology, they know immunology, they know things that I didn't know and still don't really know to this date, because they have to qualify through and pass the same standards that the cancer biologists in Moffitt. So in a sense,
sounds really scary.
It is very scary.
Oh, I would have no chance, I guess.
I don't think I would myself.
Yeah.
No. It's definitely a very challenging. So in a way, you have more support and you have more collaborations, but then also more is expected from you. And I think that
Yeah.
that's the way it should be. You basically provide better support and you expect more from people. So I think the new generations are just going to be great. I'm so looking forward then just putting me out of business.
Yeah, that sounds really good. It's really promising. Yeah. And there are really good people coming through, right?
Yes,
I met
yes.
some of them, and they're wonderful people.
That's exactly right. Like I am, if I had to apply for this program, and supposed to be the first person who has to filter out CVs, I don't think my CV will make the cut. I'm quite confident about that. The people who are coming now are so much better prepared, and it really is a delight to work with them.
This is great. Yeah.
Now, I think it's in a lot of people's minds, artificial
Yeah.
intelligence, machine learning, all that stuff.
Machine learning, right? All that stuff. Yeah.
I am
right.
not a machine learning person. I'm not. Doesn't mean I don't like it.
Yeah.
I like it, but I'm not going to be the one that determines how the field is going to move in that direction. But I feel like I know that you're going to be, or you have interviewed Jeff West already,
Yeah.
and I know that in this particular meeting he has talked about mechanistic machine learning, right?
Right, he did.
And
yeah,
I think that this is a very promising feature because you want to sort of have a way to utilize data that might not really have a meaning right now until you figure out how to sort of pass it through funnels until sort of some nugget of understanding comes out. But you want to have that shaped by mathematical models that have opinions. And I think that is one of the things that we bring to the table. Mathematical models, as opposed to machine learning, they come with an opinion. They're opinionated models in the sense that they come with a hypothesis. They say, like, what if the world worked this way?
Yeah.
If the world was this way, this is what derives from that, right? And I think that's very, very powerful.
Yeah.
So the combination of these two things, whether possible, I think is really going to change, I think, the future of this field.
Amazing. Yeah. So it sounds really promising.
Yes, yes.
So I would love to start again.
Yes, no,
Right?
no.
Yeah,
I
it
think
would be. It's wonderful. Yeah.
yes, it's a great moment to come to mathematical oncology,
Yeah,
and
so there are lots-
I'm so glad that you're doing this because I think. I don't know if I'm going
Yeah.
to use my own interview, but I've seen the people you've interviewed. They are great leaders in the field. And I think that by actually making sure that people understand what we're doing and where the field is moving and the kind of people who are working here, we can potentially attract even more bright people into this field, which I think we need because
I think
this
so
is going
too,
to
yeah.
grow.
Yeah.
Right.
Yeah, awesome. So thank you very much for the
Yes,
interview.
thank you very much.
I'm pretty sure people would really love what you're talking about. And
I hope so too.
Yeah, well, it's great to see you.
Okay, well, yeah. Thanks so much.